Welcome, everybody. Thanks for joining us today again for this new session. Today is going to be all about automate Azure Resources Decommissions with tracking. I have the pleasure to have here with me again Marcel Lupo, who is going to explain all the tricks. And actually a really top class session, because I know when people are working with Azure, when it comes to the time to remove storage, remove virtual machines or whatever are the resources, can be a little bit tricky when it comes to the permissions you need to give for people to help you. Or if you are removing a virtual machine, you need to make sure you remove all the components assigned to that virtual machine. And then in a kind of large scale for companies can be very complicated. And then this is why you brought today Marcel to make everything hopefully simple. Yes, anyway, you are seeing the code here in front of you. As if you have been following us, please just register that quick link. I will post the link in a few seconds. You can scan the code as well. And then that will basically guide you into a Microsoft page, just to provide some additional material that will complement whatever Marcel is going to explain to us today. Yeah, Marcel, if you want to do a quick intro, it's very good to have you here again. And then I can share your screen in a few seconds. And then I believe the show and the floor is yours.
Thank you very much, Jackson. And thank you again to the Cloud Lunch and Learn team for letting me come and talk again to the user group and the community here. My name is Marcel Lupo. If you've been following Cloud Lunch and Learn, I've been doing a few sessions here lately. I'm basically a DevOps architect manager at Avanade, and I've been working in the cloud and IT space, technology space for about maybe over 20 years now. And yeah, I kind of look at automation. Automation for me is really important, and DevOps. And I kind of look at how you can, in the modern day, as part of an IT operations team, you can make your life easier through automation and DevOps. And today's talk is going to be quite interesting, where we're going to talk about one of the things from the Cloud Adoption Framework, and that is how we maintain the life cycle of our Azure resources. So thank you very much for joining this session. Hopefully you'll learn something cool and something fun in the session. And thanks to Jackson as well, the host here, for inviting me tonight. Thank you.
Okay, great. Yeah, I'm looking forward myself for this session, because of course, if you're managing Azure, just a couple of VMs, a couple of storages, you can pretty much do, let's say, with the graphic user interface yourself. It's not a big headache. It's not that time consuming. But when things are getting, let's say, more complicated, and you are adding more and more resources, and usually this is what's happening with the companies out there. They started slow, especially if they haven't done any work on Azure. They started slow with a couple of VMs, a couple of storages and other resources. But and then, by the time things get, let's say, bigger and bigger, and then anything that we can automate, of course, we can always save time, and to make sure using the right script, everything runs with no, let's say, human error, that make things simpler. Okay, Marcel, let me just share your screen here. Yeah, that's pretty much it. Yeah, everybody watching us now, if you have any questions, I think Marcel is better for the guys just to type the questions as it comes. And then I will basically just kind of read the questions to you, and we can have hopefully a good discussion and make the session more interesting. Okay, Marcel, yeah, I will be here on the background, and if you need anything, let me know. Otherwise, yeah, the floor is yours, and yeah, just take over, please.
Thank you. Thanks, Jackson. So the opening slide here, as you can see, we're going to talk about automate Azure Resource Decommissions with tracking. My name is Marcel Lupo, as I said, DevOps Architect Manager at Avanade, and my Twitter, LinkedIn, my blog page, and my GitHub page is on the screen here as well. You can come on Twitter and ask me any questions as well if you want. So before we start this session, I've got a few slides that I want to just talk about. So first of all, I want to talk through the what and why. So according to the cloud adoption framework, we have Azure resources, like Jackson said just a moment ago. Maybe we start off small with a few resources, one project, one project turns into 2, 3, 4, 100 projects. At the end of the day, we have so many resources. And, when assets that are no longer required to support business functions, they're considered as retired and they can be basically decommissioned. Because everything, that will reduce operational costs. Because everything in Azure and any cloud provider that you build, you get paid, you pay for those resources, usually per minute or per second, whether that's VMs running, whether it's storage. And, when things don't really, this is quite an attractive thing about cloud, is if you don't use something, you don't have to pay for it. But that's not necessarily always the case. Sometimes if something is there, you will pay for it even though it's off, because maybe it's consuming space or storage, even though it might be small. And in the beginning, it might seem like a small amount to pay, but as things build up and build up and build up, those costs will essentially be just wasted costs. So when cost savings is a primary motivation, decommissioning is an important step for us. Until an asset is decommissioned, it continues to consume things like power, environmental support, and other resources that drive costs. So after the asset is decommissioned, then obviously the cost saving can start to be realized. So that's basically what we're going to talk about today, is the life cycle and how we can ease that process of maintaining the life cycle of a cloud resource. So some of the challenges and risks with this is, like I said earlier, if it starts off small, but when it goes so big, sometimes you can lose track of resources in an environment, like what's in use, what's not in use. And it's very difficult to manage and maintain for an operations team, especially if there's other teams in Azure that has the ability to build their own stuff, and you kind of just lose track. So forgetting to decommission retired assets can lead to unnecessary costs. Not monitoring or tracking resources and assets can lead to losing track of resources also in different environments. And inefficiencies by retaining retired assets can cause costs to rise with no real benefit gained. Now, one way that we can look at solving this issue is through automation. Now, as most of you who is already working in Azure is, you probably know that you can tag resources and with metadata. So for example, tagging resources, you can classify resources, you can put descriptions against resources. You can sometimes tag resources with cost centers or cost codes to kind of group things together for a certain cost. Now, we can basically make use of this tagging metadata to automate the life cycle of an asset through tagging. So automated decommissioning gives more control over the decommissioning process to basically not be missed or forgotten about. You can also use the tagging to monitor resources that has got a decommission tag. So basically what we're going to do today, I'll go a little bit into what we're going to actually do before I go through the rest of the list here. If you can imagine you have a server in a data center that is a script server. Say you have a bunch of scripts and you're running your server and you're scheduling these scripts to run as scheduled tasks. Maybe at midnight, this runs. At 4 p.m. this run, and you just have a server that's running and it's running scripts on a schedule. you're still paying for this server, essentially. So what we're going to do in today's demonstration is we're going to build a serverless function app, a Windows-based function app. Now, if you don't know what a function app is, it's basically a service in Azure, a PaaS service that we can create a script that runs inside of an environment that that will spin up, run the script, and then spin down again. So essentially, we're only paying for the run of the script, the runtime of the script. And what we can do with this function app is we can basically create, instead of having a server running our scripts, we can have our script just there in the cloud, and we're just going to pay for it when it runs. What we're going to do is we're going to create a script that is going to connect to our Azure tenant, and we can use this script to basically scan one subscription or two or three or how many ever subscriptions we want. And this script is going to basically look for a tag on resources. Now, a tag is basically a key value pair. So the tag key is going to be called decommission, and the value is going to be a setting that a value that we can set in day, month, year format. So what we're going to essentially do is we're going to say, I want to tag my resource with a date that I want that resource to be decommissioned. What's nice about this is our automation script will basically take all of those resources. It will run every day, say at midnight, and it will go and get all of those resources that is tagged with a decommission tag, and it will evaluate the date. If the date is today or prior to today, it will remove the resource. But also, it's going to track that decommission by putting the resource that it's decommissioned and the date it decommissioned it into a tracking table storage to say, so that you have an audit log of the automation and what it has decommissioned. It will also log failed decommissions, and we'll go through a failed decommission as well in the demo. But basically, reporting and monitoring will be possible through the tagging. And another important thing about this automation is if you're a single person or maybe a small team that's looking after a huge enterprise, and your duty is to build resources and then decommission resources for other teams, this can become really overcumbersome. So maybe you can think about, oh, well, I can give that team access to be able to delete their own resources, but then that is also like a bit risky. You have to almost give them God mode permissions to be able to delete resources, and that's scary. You don't want a team that maybe doesn't realize what they are capable of by deleting stuff by accident. So a nice way is to basically still have that self-service option. Instead of giving a team the ability to delete resources, you can give the team the ability to just tag resources. And then you can say to them, listen, if you want your resource decommission, you could just put a tag on that you manage yourself, just call it decommission, and then just put a date against that. And our automation that we're going to set up will just take care of that on that date. So that's a bit of a better way to kind of make the decommissioning lifecycle process more of a self-service process by using automation and not granting loads of people, over permission them to be able to delete lots of stuff and potentially delete things that are that should not be deleted. It just gives it a little bit of a better way, I think, to delegate. So, decommissions can be also kind of be blocked. So we can actually block our own automation by using something like resource locks. And I'll show it an example of that in the demo. And then, basically just continuous monitoring and tracking, because we're going to track everything that's being decommissioned, whether it's successful or failed, is also a good way to keep a register of removed assets from your your cloud environment. So that brings me to the end of the slides, the boring bit. I'm going to basically go straight into the demo and show exactly what we're going to set up. And we don't really need to set up a lot of things in Azure to make this happen. I do have these scripts are also available on my GitHub. So in the beginning of the video, if you have a look on my blog, there is also a blog version of this demo and the scripts if you wanted to go and have a look at implementing this in your own environment. But basically all that we're going to do is we're going to set up a few variables. I've got here a script that is basically a PowerShell script, and it's just going to run a few Azure CLI commands just to set up some of the prereqs and some of the things we're going to need. It's going to basically set up our serverless function or our script in Azure, you could say. So we're going to create a resource group called Automated Resource Decommissioning. We're going to create a storage account and a function called decom function with a random number. Now, when we create an Azure Function app, an Azure Function app needs a storage account already. But what we're going to do with the storage account is we're going to create an extra table in the table storage called tracker. And we're also going to have a table called filed. And we're going to actually use these two tables of the storage account to track our successful and our failed decommissions. I want to also show you that the scopes, so our function app is going to have permissions over our subscription to be able to scan all the resources for this decommission tag. And it's also going to have the ability to remove the resources that it's evaluated that needs to be decommissioned. But say, for example, you have multiple subscriptions in your Azure tenant, you can expand the scopes. So say, for example, you can add here ID2. If you have a second subscription in your tenant, or you can add ID3. In my case, I only have one subscription, but I'll go a little bit more into the scopes here in a moment. You can actually see that I'm getting the, just gonna remove that. It's a bit of lag on my keyboard, but you'll see here I'm actually getting the subscription ID of my subscription, and because I'm just going to use the function app for my subscription. So we run that, create the storage account. We're also going to create the resource group. We're going to create the storage account for the function app. Then we're going to create the function app itself. You'll see here that it's a Windows based function app that is running PowerShell. And I'm also using a setting called assign identity, because I want to give my function app the ability, I want to give it an identity. Why would I want to give it an identity? This function is going to basically be a script that is going to scan my subscription for resources. So it has to get permissions to do that. And I can assign permissions to an identity. And that's why I've used the assign identity tag here. So I can give my function app the right permissions over my subscription. I'll also be setting up some settings, the app settings, and I'll go into this a little bit more detail. But basically, inside of our function app will be a PowerShell script, and we can get variables into our script from the function app environment variables or the app settings. And I'll show you that once this is built. I'm also giving some permissions to be able to create the table storages, and then I'm creating the table, the tracking table, and the failed table, and then I'm also giving my function app identity access to the table storage to be able to read data and to access the table storage to be able to audit what we're decommissioning and what we're not, like what's that was successful and what was failed. And then I'm also giving my function app the contributor role over my subscription. There is another setting here that I'll go into. So once you've run this script, let me just jump into Azure. It's going to basically have this resource group that I created here, automated decommissioning. I'll make my screen a tiny bit bigger here. So that looks a little bit bigger. So all that's created was a resource group called Automated Resource Decommissioning. And you'll see here is only a handful of resources. There is my Function app, my Function app storage account, my Function app's consumption app service plan. Now, what a consumption app service plan means is basically my function will run on a trigger, a time trigger. So it's almost like a task scheduler. Imagine that scenario where I said earlier that you have a server that's running, you have a bunch of scripts that's scheduled to tasks, and the task scheduler would just run your script. So what's nice about a consumption plan is our script that's going to run is actually on, in the background, there's going to be a server, but the server is off, so we don't pay for it. When the script triggers, it will power the server up, it will run the script, and then it will power it back down again. That's pretty much essentially, in a very basic term, what is happening with an Azure Function app. And that is using a consumption plan, meaning we're only paying for the consumption. We're only paying for the run of the script. And to be honest, to run the script takes, on a daily basis, costs about 3 pence or 2 pence. It's very, very little. So it's created our function. Let's take a quick look at the function app and some of the things that I spoke about in the script. So if we first of all look at the identity, we'll see that the function has been assigned a system assigned managed identity, and we can use this identity. You'll see the function name is called decom function 3216. Now, if I just quickly jump back to my subscription, and we'll have a quick look at the permissions on my subscription, you'll see here that my function app is actually a contributor over this subscription. So it means that the script that's running inside of this function will have the contributor ability over my subscription. It needs that because we'll be reading tags, and we will be decommissioning resources with this function. So if I just quickly go back to the function, the other thing that we've set up in this function is, or the other thing that we have to set up on this function is under app files. I'll load that up. There is a drop down here called requirements PSD, and we just add these 2 lines in here. Now, what this means is because we're going to use a PowerShell function app, it means we're going to use PowerShell scripts inside of our function. What these 2 lines here does is we can instruct Azure or the function app PaaS service that when it's spinning up that VM that's going to run our script, we want certain modules to be available. And this is where we will configure that. We want the AZ module, because we're going to work with Azure PowerShell. We're basically loading that module into the function when it starts up. We're also going to use a module called AZ table, because we're going to write data. We're going to track what we're decommissioning into table storage. So for that, we'll use the AZ table module. So this is quite handy because we can configure multiple on different lines, different modules that we want to consume within our function, or maybe that our script needs to be able to function, which is a pretty cool. The other thing that we've set up was the app settings that I was talking about. Let me just quickly jump back to the script here. You'll see here that I'm creating some app settings, and then I'm setting these app settings. I'm doing something called function scopes, function resource group name, function storage account name, table name, and table partition. If we go and look at the configuration of this function, you'll see now that there are function resource group name, function storage account name, scopes, which is my subscription, the table name, which is tracker, and the partition inside of the table that's going to be called decommissioned. Now, remember I said earlier that if you had more than one subscription, you can add them. So basically, what you would do is that variable basically just sets the scopes here. So if you ever wanted to add additional subscriptions, you could just come into the actual function and come and add all your subscriptions this way, or you can do it when we set this up running that script that we did a bit earlier. But I only have one subscription, and then so I'm not going to add any more subscriptions because my scope for this function is only going to cover my subscription. And if you add other subscriptions, just make sure that you go to those subscriptions and ensure that you add, let me actually remove my function permission, just because I want to show how, if you had additional subscriptions, how you could add the function to cover those subscriptions. So say for example, you added a new subscription or a second subscription that you want to kind of check or scan. I'm just going to remove that. So say this is my new subscription. I'll just come in here and add a role assignment, and I'm going to add a contributor. And you'll see here that I can select what to give access to. Remember, our function app uses a managed identity. I can then select the member, and I can see here, oh, here's function apps. Which one was it? It was the decom func 3216. I'm just going to add that. Oops. Oh, that was in the way. And I'm going to review and assign. And there we go. And there it's back there. So that's how these two things are kind of linked. You need to make sure as well that you basically give the function app access. Now, I've already set up my function here called resource decommissions. What I'm going to do is I'm going to just delete this. Or let me just disable it for now. But what you could do, once your function app is created, this will be blank. There will be nothing here. This brings me to the second bit, which is the run script. And this is now going to be our script that we want to run every night at midnight to go and check all of our resources. So when we're creating a new function, I'm just going to hit create here. And it's going to tell me, do I want to create a function? I'm going to say, yes, I want to create one in the development portal. And I want to use a timer trigger. I want to kind of almost use like a task scheduler. If you remember that server with the task scheduler that's just going to run our scripts. I'm going to create a script or a function, and I want that to run on a timer, on a certain schedule. So I'm going to create that. And you'll see here it's called timer trigger. Now, if I go into that and go to integration, I can actually, under trigger and timer, I can look at the binding, and the binding is called timer. And this schedule is basically a cron job. If you're not familiar with cron, I quite like a website called cron guru, because I'm not a cron guru myself, so I kind of use cron tab guru to work out my cron jobs. Now, how a cron job work is basically you have from the most left to the right position, you have seconds, followed by minutes, followed by hours, followed by days, months, and days of the week. So according to this schedule, my function is going to run every 5 minutes because it's set there to run every 5 minutes. But what I want to do instead is I want this to run, remember it was seconds, minutes, hours. I want this to run 1 minute to midnight every night. So I'm just going to copy this cron expression. 0 is seconds. We're not using the seconds one, so I'm just going to paste that in there. What this now is going to do is it's going to basically run my function at every night at midnight. Now we don't have a function yet. We're still just playing with the timer. So if we go into our function now, and we go to code and test, because this is a PowerShell Windows-based function, when we go into the function for the very first time, you're going to see it is actually has a file called run.ps1. And this is just almost like a very basic template of a PowerShell script. Remember on the integration tab, we have a binding called timer. If we go back to our code, you will see that the parameter, there's actually a PowerShell parameter called timer. So what's happening is the function will inject the cron timer or schedule to basically trigger this function and just go, what is the current time? If it's past due, then the PowerShell timer is running late. Otherwise, the PowerShell timer has been triggered. It's just a very basic script. Now, what we're going to do is we're going to actually replace this script with a script that we want to run instead. So if we go back to my version of the, this is just the default bit that we just looked at. If we look at the script that I'm going to replace in that function, so if I just copy this code, and what I'll do is I'll just put that in here and save that. That is it. That is our function done. I'm just going to delete that just to because I have one here already. So I'm just going to delete that, and then we'll go through the code and look at exactly what this thing is going to do. Let me re-enable that one, and that's re-enabled. Just refresh this here real quick. Okay, there it is. And if we go into that, we'll see that again, it's going to be the same code as what I've got in VS Code here. So let's go through this code real quick. So we know the first bit is kind of the default bit that we looked at when we created the function. In PowerShell, we can, in my PowerShell script, what I've done is I've written two PowerShell functions. The first function is called get resource group for decom. And the second function is called get resource for decom. And I'll go through these in just a moment. But these are just kind of functions that it's not actually my script. My script is starting here. And we'll go through this in just a moment. But let's look at this first function first. So remember, when this function app spins up at midnight, it's going to run this script. It's going to import the AZ module and the AZ table module into memory, so I can actually use that or consume that inside of my script. So if we look at the first function, we can see that I take a few input parameters. One is going to be subscription ID. One is going to be resource group name. And another one is going to be a tag key called decommission. And then a switch called future. We don't actually use future in this demo, but I'll explain what that means as well. What this function is essentially going to do is we're going to connect to a subscription, and we're going to get the date in the format date DDMMYYY. And this is the date format that we use in the UK. If you're in the US or another region, you might use a different date format. You can come and actually just change this to whatever format your region uses. But because we're my region is the UK, I can set my value to DDMMYYY. So basically, we're just getting the date of when this function is running. We're then creating a object of where we're going. Now, remember, our function will have the AZ module loaded up. So I can actually now run Azure commands in my function. So I'm going to say, go and get me all of the resource groups in my subscription and all the tags of all the resource groups. If the future switch is not used, the future switch is only kind of used to check what stuff is up for decommissioning. But if it's not used, if that switch is not used, what I want to do is I want to look at the dates where my current date compared to the date of the resource is less than today's date or equal than today's date. So if I go back to Azure real quick before going back into my script, I'm going to create a resource group. I'm going to call it RG1 in UK South. And I'm going to create another one. I'm going to call it RG2 in UK South. And I'm going to create RG3 in UK South. Just 3 resource groups. They're over there, those 3. Now, for my first resource group, say, for example, this had a bunch of resources in it. I'm going to put a tag on the resource group, and I'm going to call it decommission. And today's date is the 23rd of March. So I'm just going to put 23, which is the day, month, and the year. So I'm putting today's date. I want this resource group to be decommissioned today. My second resource group, I'm going to put a decommission tag. And I'm going to say, I want this to be decommissioned maybe at the end of the month on the 31st. So I'm going to go 31st. I only need this till the end of the month. So I'm just going to let my function decommission this at the end of the month. And my third resource group, I'm going to do the same. I just want to say at the end of the month. In my third resource group, I'm going to create a storage account. They're probably the easiest to create. I'm just going to create a storage account. And I'm going to call that, I'm going to put that in resource group 3. And I'm going to call that PWD 9000 SA01. Doesn't really matter on the region, but let's do UK South. And what I'm going to do is I'm going to put a tag to decommission this single storage account. Today. It's going to create that. And we can see, I don't know if I've created that actually. No, that didn't create. Let me just do that again. Create the storage account. That's PWD 9000 SA1 and create a decommission tag to set to today. that's actually kicked off. And then what I'm going to do is I'm going to create one more storage account. Just one more storage account, and I'm going to call this one okay. So my storage account went into a different resource group. It doesn't matter. I'm going to call this PWD 9000 SA02. Say that one's in West Europe. And I'm going to say for this one to decommission as well today. If we just have a quick look, I think my first storage account went into this resource group here. You'll see here, there's my PWD SA01 in the automated resource decommissioning resource group. And if we look at this storage account, you'll see that it's got a tag here called decommission on today's date. And if I go to my resource group 3, just takes a moment for the storage account to show up, you'll see that there's another resource, a decommission here for today for my second storage account. But what I want to do with this second storage account is I'm going to put a lock onto the storage account. And this is a good way as well. If a team, say for example, a team member puts a decommission tag on a resource, but another team member goes, hang on, I need the resource for a few more days, and kind of wants to block that decommission, you can put a lock on the resource. And what I'm going to do here is I'm going to add a lock called prevent delete. And it's just going to be a delete lock. And then I'm just going to say, you know, do not delete. Now, what's going to happen is when our automation runs and tries and decommissions this specific storage account, it will try to do it and it will fail. But this is where our tracking comes in. So with this all set up, I'm just going to quickly jump back to these functions that I was talking about here. So the purpose of this first function in my script is to basically get all of the resource groups and all of the tags of the resource groups. And then what it's doing, it's evaluating today's date with the date of the resource. It's looking for the tag key, which is called decommission. And it's saying, give me all of the resources that has got this tag key called decommission. And then what I want to do with those resources is evaluate whether the date is the same as today's date or less than today's date, meaning it's in the past. If it's true, it's got decommission and the date value matches, it's going to return the resource group as an object. So we're going to get the resource group ID out of this. This is basically what this function is doing. It's all that this function is tasked to do. The second function is very similar. Because we can tag in Azure, we can tag resource groups and resources separately. We want to have a second function that does the same, but for resources. So this is essentially going to look through all the resources and do the same. It's going to return the resource, whether whether it's viable to decommission or not. And then here starts our script. Now remember when I said earlier if I just quickly jump back to the function, inside of our function, we have a configuration that is going to be our app settings. And remember I said we have these app settings called function resource group name, storage account names, function scopes. So these values, we can actually use these values inside of our script. And how do we do that? So because this is a Windows-based PowerShell script, what we can do is the environment variable called function scopes is that app setting. So we're going to say, we're going to create a scopes variable inside of our script and says, just get the value from our function app settings, the environment variable. So this is quite a cool way that we can consume variables into our function or into our PowerShell script from the function app. By not even having to come and configure anything in our script, we can just configure the app settings with things that we want this function to do. So basically what we're doing is we're connecting to the storage account that's coming from our function app settings. And we're going to say, for the resources that are matched, meaning the resource groups that needs to be decommissioned today, we're creating a list of IDs, of resource group IDs, and we're just saying, for each of those IDs, we want to remove the Azure resource. What we're doing in this for each, we're saying each of the IDs, we want to remove the resource. And what we're doing inside of that, what this $question mark means, it means just if the previous process was successful, you'll see here we have an error action that says continue. Because basically what we want to do is we want our script to run from start to finish. We don't want our script to fail or exit. We want it to continue running, because we might be able to decommission some stuff, but some stuff might have locks on, and we don't want those to make our script error. And that's why we have error continue. And what we have is a little bit of logic here that says, if the decommissioning was successful, write the resource group ID or the resource ID into the tracker table. And if it was failed, write the resource ID to the failed table. So this way we can easily check and see what worked and what didn't work. And the same happens with the resources. And this is basically all that our function is going to do. So just going back to the function, we have a resource decommission function that's going to run at midnight, and it's just going to do all of that. Now, let's test this. Let's test this out. Remember, I created resource group 1, 2, and 3. I'm expecting resource group 1 to be decommissioned. 2 and 3 should stay. I also have storage account 1 that I expect to be decommissioned because it's got a tag. But my resource group 3 has also got a decommission tag for today, but it should fail because I have a resource lock on here that says, don't delete this. No matter what, I want to keep this. Now, let's run our function. So if I just come back into the function here and go into the function, we can manually trigger this. We can wait. I mean, we could stay on this session here until midnight if Jackson likes, and we can then wait and let it run at midnight, or or we can basically trigger this manually. So what I'm going to do is I'm just going to go into the function here, and there's a button here called test run. I don't have to give any input parameters or anything to this function because it's all self-sufficient in that script. So I'm just going to click on run. What's happening now in the background? Let me just see if I can maximize this. Hopefully we'll be able to actually see what's happening here. It's got a live log. So you can see here, it's actually running the script. It's connecting to my subscription. It's going to go now and look for all the resource groups with a tag called, you see it loading in the module, the AZ module. It's almost like running the script on a server, pretty much, is what this function app is doing. Spinning up an instance and executing the script. So it's currently loading that AZ module into the runtime, into the memory of the runtime. And what it's going to do, it's going to go and get all of the resources and all of the tags. And it's going to look specifically for resources that has got a decommission tag. And you can actually see here, it's decommissioning resource group 1. Because resource group 1 had a decommission tag for today. So it's going to decommission that. It's obviously going to leave resource group 2 and 3 alone because now it's just writing that entry to table storage. It's going to leave resource group 2 and 3 alone because they have decommission tags, but it's scheduled for the end of the month. It's not going to be, it leaves the ones for the 31st, what we set. So the next thing it's doing is going now and checking. So there is kind of an order that it does it in. It does the resource groups first, and then afterwards it will do the resources. The reason why we do resource groups first is because resource groups contain multiple resources, and they're kind of the low-hanging fruit. We want to kind of get rid of all those first, because we don't want to go and scan all of the resources when, this resource group could have had 100 resources in it. We just want everything gone. So that's why we do the resource groups first. And you can see here that the second decommission was the storage account. Sorry, storage account 1 would have been decommissioned. But you'll see here a bunch of red, and that's because the second storage account failed. If I go back to Azure now, back to my resource groups, and I refresh, you'll see resource group 1 is gone. If I go to my storage account, you'll see that the storage account 1 is gone. Now, if we go to resource group 3, you'll see my second storage account with the lock is still there. Now, let's just take a quick look at the tracking. If I go back to my function, my function's storage account, in my storage account, remember I said there's two tables. There's a file table and there's a tracker table. So if I go into, let's have a look first at the tracker table. And I can see here that the tracker table decommissioned. If I expand this, it gives me the resource ID. You can see here that it's decommissioned resource group 1, and it gives me the date as well and the time that it did that. And the second resource that it decommissioned was my storage account 1. That's all good. Now, if we look at the failed decommission, you'll see that's failed and storage account 2. Now, say, for example, you leave this for a couple of days and you come back to it and you see, oh, I have a few failed decommissions, but you're not sure why it failed. So what you can do is you can go back to the storage account and, sorry, not the storage account, the function. If you go into the function, there is a section called monitor. Now, in monitor, you can actually go and look at every single, because mine is running every day at midnight. And you can look at every day's decommissions by going into the monitor. So let's look at the latest one. I don't know why that storage account failed. I want to find out why. So I go into monitor here. And what this is going to show me is it's going to actually show me all of the output of the PowerShell script that run. It's going to show me the storage account 1 that it decommissioned. It's going to show me the resource group 1 that it decommissioned. And look, it also gives me the error of the second storage account that failed. And if we look at why did this fail, you can see here that please remove the lock and try again. It knows that the scope is locked. There is a resource lock on this storage account, and that's why it couldn't decommission it. Now, I actually, that brings me to the end of the demo. And what I wanted to tell you or show you, I'm not going to show you in this demo just because of the time.
Yeah, Marcel, just let you know we have 6 minutes.
Yeah.
Sorry for the pressure. Just to try to keep things on track.
yeah. I'm pretty much finished. But what I want to say extra is I actually created a third function because what we can actually do is, if you are aware, there's a service in Azure called SendGrid. Now, what SendGrid is, it's a SaaS service that you can set up, that you can sign up to. they have a free tier. Now the free tier gives you it's basically an email service. So you can use 300 emails on the free tier. I actually wrote a function that if you have a SendGrid account in Azure, you can just stick the SendGrid function in here. And then what you can actually do is when this function is running, if the tracking table is not enough for you, you can actually tell this function to also send you an email or maybe a group of people or stakeholders an email to say, these are the things that were decommissioned. Or you could say, if something failed, email me what's failed and email me the error. So almost like a notification system. So I do have that as well, a blog of that. I didn't put that in this demo because of time. But basically, if you go to my blog or my GitHub, you'll find all of these scripts. And to set it up is really a 10-minute job. And you can kind of automate your decommissioning process in this way. And that brings me to the end, basically, to the demo. And I hope you liked it. I've not seen any questions, but if there's any questions, I'm on Twitter as well. Over to you, Jackson.
No, yeah, there was no questions, but yeah, there are a couple of compliments. The guys here, DR and Krishna Nag, they really liked your presentation. That's great. Yeah, it was when you were running the demo. I kind of remember years ago I helped a customer. He was running a project in a SharePoint. Let's say he was running a kind of IT project, but all the management was in a SharePoint site. And then he said, "Oh yeah, for compliance, requirements, when the project is done, we need to wait 6 months, and then I need to make sure all the SharePoint site is fully deleted because we are not allowed to keep any information." And then let's say from the SharePoint, let's say tools, that time I started setting some triggers for after 3 months for everything to be deleted. And now looking your presentation when it comes to SharePoint, yeah, we can do kind of easily with all what you said. Eventually a project could be running and using VMs and storage and SQL Server database and so on. And then after 6 months, everything must be absolutely deleted. Yeah, that could be a really good way to achieve that. That's really great.
Exactly. And one thing that I've seen with if you're an operations team, especially if you're a small team looking after many people, right, you sometimes lose track. So for example, a team will say, Jackson, you need to decommission this on day X.
Yeah.
But you maybe are so busy, so you're running, maybe you forget, or maybe you just run 2-3 days late. But just that 2-3 days late is that is cost that is wasted. So rather than going back and decommissioning it, what you can do is you can be clever and say, I will build this for you now, and I set the decommissioning tag now, and then you forget about it.
That's it.
Yeah, and then that tag, you won't forget about it because that tag will on that day it will decommission it. So you're kind of you're never late, or you don't run into that.
That's correct. Especially in Azure, you pay for everything, as you said. Even if the virtual machine is not running, but of course you still have the files, the VHD files. Somewhere you are paying. And good example from you. Eventually, if you miss, let's say 3-4 days, you are paying for that.
Yeah.
Okay, I think that's really great. Thanks everybody one more time for joining us. And if you have time, it will be great to have you back next Wednesday. It's going to be our presentation is going to be a cloud journey a customer journey to the cloud. Starts here, some kind of good tips for those looking to move to the cloud. And hopefully you enjoy. Thanks very much, and please register for the link I just provided a few seconds. Okay, Marcel, thanks very much one more time for your time, and everybody watching from home. Yeah, thanks very much. Have a good week, and see you next time. Stay safe. Thank you. Bye.
Have a good night. Bye-bye.
Yeah, you too.